Started then, everyone. So we're continuing on with confidence intervals. So I'm going to go through both 9D.2 and 9D.3 today. My explanation is very short, and then we'll allow you both Wednesday and Friday to work through both of these exercises. Again, continuing our cruisy pace through this term, giving you ample time to work on the folio task. So what we're talking about here is we have a confidence interval, but it's got a certain width on it, right? So we did the 95% confidence interval for height yesterday, and we saw it here. And so that's a width of about 5 centimeters. The width is the upper boundary, take the lower boundary. Okay, so we can see that would have a width of just below 5 centimeters. Now we can decrease the width of the confidence interval in two ways. Okay, the first is that we can lower our level of confidence. Okay, so we can go from a 95 to a 90. If we're stating it with less confidence, we can narrow the width of the confidence interval down. Or we can increase the sample size. Okay, we can increase the sample size, and then our sample mean is going to be more indicative of the true mean. And so that's what this formula is here. It's saying how many people do we need to sample in order to guarantee a certain width. Now, this formula here that I've stated up is clearly, if we're becoming familiar with it, for the 95% confidence interval because of the 1.96, and so we can find n for other values of confidence just by changing that number. So in our circumstance here, we're going to continue on. We have the height of 40 Year 12 students, from our sample, 178 centimetres, standard deviation of 8. How many people do we need to sample to have a width of 2 centimetres? So we want to sample lots of people to really concentrate that width with a 95% confidence. So all we're substituting into this formula then is the standard deviation and the width of the confidence interval we desire, which is 2, and that's our formula. Now when I'm typing this kind of thing into my calculator, I'd be looking at, like, we've got 2 at the top, 2 at the bottom. That's going to cancel, so it's 1.96 times 8, and then that's squared, so 16 squared-ish. So we can already anticipate a result. Squared, 245.8. Now, let's talk about this number. When you calculate n to guarantee a width, you always round up in order to guarantee that width. Because if you round down, it won't guarantee that width. It will be a little bit wider, so we always round up. Even if this is 0.01, you round it up, always, to guarantee that width. So that's going to take us to 246 students. If we sample 246 students, the width will be less than or equal to 2 centimetres for the confidence interval. Okay, so that's what we're doing in the first exercise, 9D.2, and it does develop a little bit more complexity than what I've explored here. You'll explore other levels of confidence, as well as manipulate this equation to solve for W. Okay, so given a sample size, what's the width that you're going to get? So we can rearrange that to get W. We'll deal with that as it pops up in the exercises. So that's 9D.2. Then on to 9D.3. What we're doing is we're looking at using confidence intervals. How can we use confidence intervals? To test a claim. In statistics, people are always making claims, and confidence intervals are used to either support their claim or reject their claim based off of the evidence. So let's have a look here. Jimmy claims that, so this is 95% confidence interval that we developed yesterday for the height of Year 12s. And then we've got this fellow called Jimmy. He claims that the true mean height could be as high as 182 centimetres. Is he correct? So based on our confidence interval that we're calculating, we're 95% confident that the true mean lies in this window. Okay? Now 182 is here. It's outside of the confidence interval. So there's no evidence to suggest that he's correct. All right. So the way we should describe that, we're talking about Jimmy. We'll call Jimmy part A. We'd say there is insufficient evidence to support Jimmy's claim. Claim as it lies outside the confidence interval. As it lies outside the confidence interval. So it doesn't say Jimmy's claim is true or Jimmy's claim is false. We never state things definitively, all right? So like in all of science, I'm going to say something very controversial, nothing is ever proven. We only have evidence that supports things and evidence that doesn't support things. Nothing is ever proven deductively in the manner it is in maths. So there's insufficient evidence to support Jimmy's claim. And then we look at Alex. So Alex is a girl, is her claim correct? Alex claims that the true mean height could be as low as 176. Is her claim correct? So 176 is here, it falls within the confidence interval. Therefore, the confidence interval supports her claim. All right, so it's not that her claim is true, but that evidence supports her claim. So for Alex, we would say there is sufficient evidence to support Alex's claim as it lies within the confidence interval. Excellent. So just be careful when you're assessing claims and when you're rejecting claims. We're always doing it based off of evidence. And as we lead up to the test, we'll pull out some exam questions that really focus on answering. Maybe we'll do some Friday actually. If I'm not teaching on Friday, we'll maybe go through a few on Friday too. Just about assessing whether evidence supports a claim or whether evidence does not support a claim based off the confidence interval. Excellent. So that's enough.